Hello and welcome back. 7.2, we continue our work with inverse trig functions. We'll look at some sines, cosines, and tangents, then we'll get into the other three. So we'll do the sine of the arctangent of 3/8 to start us off. We'll kind of walk through the reasoning on that. So sine of the of part is usually an angle. We'll call that theta. So we're going to let theta equal the arctan of 3/8. Remember, arctangent, there's two common notations for that. I wanted you to kind of be exposed to both. So if we take the tangent of both sides, tangent of theta is then equal to 3/8. And please recall also our domain when we're working with the tangents and we want to keep a 1-to-1 function. That is from negative pi over 2 to pi over 2. At pi over 2 or negative pi over 2 on your unit circle, the cosine is 0 and the tangent is undefined. That's why we have open parentheses on both of those. So here, though, our output is positive, so we're looking then at Q1. So we're in quadrant 1 when we make our quick sketch. So the tangent is worth 3/8. So the tangent, remember, that is our sine over cosine or our y over x. So our y and x respectively. So y is 3, our x is 8, and then our radius, of course, we can find using just our Pythagorean theorem. So leg squared plus leg squared is hypotenuse squared. So radius squared is 64 and 9, so r is root 73. So then sine of, we let theta equal this arctangent thing. So sine of theta sine is, as you'll recall, adjacent over hypotenuse. Cosine is adjacent over hypotenuse. My apologies there. Brain fell asleep for a moment. Sine is opposite over hypotenuse, so we have 3 over root 73, which is 3 root 73 over 73. All right, let's play with another one here. So we're going to do the sine of the arccosine of negative 1/5. So recall with cosine, to avoid division by 0, we were actually on 0 to pi. If you remember the sketch of cosine. So cosine of 0 was 1, cosine of pi over 2 was 0, and then cosine of pi, we were at negative 1. After that, it would start turning around. Same thing back here. It would start turning around and would no longer pass the horizontal line test to be a 1-to-1 function. So here we're looking on 0 to pi. We are allowed to use these since we're not forced to divide by 0 on those. So theta is on that interval somewhere, including possibly on the endpoints. The fact that we have a negative here for an output, that means theta is, pardon me, in quadrant 2. So we're looking, remember, from 0 to pi. Well, if cosines are negative, we're over here in Q2. So in quadrant 2, we make our triangle. Kind of sketched a little too much on that one. So I'll go ahead and put another one on there, and we'll put our triangle in there. So we're going to let theta equal our cosine of negative 1/5. So cosine of theta is negative 1/5. So our hypotenuse is the 5 here. Which would make our x value the negative 1. So it's just the y value that's up for grabs now. So 1 squared plus y squared equals 5 squared. So y squared is 24. So y equals, since we're in Q2, we won't need the plus or minus that we would usually have. Root 24, so that's root 4, root 6. So y is 2 root 6. So then that is our y value. So we want the sine of, here's our theta. So sine is opposite over hypotenuse. So 2 root 6 over 5. Have you all try one out. We'll do the tangent of the arc sine of negative 1/6. So go ahead and pause that, see if you can solve that, and we'll finish it together. Okay, welcome back from pausing it. So here we're looking at sine. So theta here is going to be an element of the interval negative pi over 2 to pi over 2. So we're looking here to here on the unit circle. We're looking at a negative, so that means we are down here somewhere in Q4. So theta is our arc sine of negative 1/6. So sine theta is equal to negative 1/6. So here is our theta. Here is our nice pretty right angle there. So our hypotenuse is 6, a radius of 6, and our y value is negative 1, so absolute of negative 1 down here. So we can get our x from our old friend, the Pythagorean theorem. So x squared plus 1 squared is 6 squared. So x squared is 35. And we're going to the right, so x is positive, so we don't need the plus or minus, so x is root 35. So then our tangent of theta, tangent is our y value over our x value. So our y value is negative 1. Our x value we figured out was root 35. So that is negative root 35 over 35. So just multiply top and bottom by root 35. All right, so then our friend the arcsecant, arccosecant, and arccotangent. If y is equal to the arcsecant of x, that's equivalent to saying that secant of y is equal to x. So remember that the secant is related to the cosine. So on the cosine, our bounds were 0 to 1, so y is on the bound, or 0 to 1 pi. Recall also, though, secant is the reciprocal of the cosine, so we don't want cosine to be where 0 doesn't have a reciprocal. So we're also going to say that y, we can just say not equal to, we didn't have to use an element there, not equal to pi over 2, since pi over 2 will not have a reciprocal. Same idea with the arccosecant. You take the cosecant of both sides, cosecant of y is equal to x. So cosecant is related to sine. Sine is negative pi over 2 to pi over 2. Recall also cosecant being a reciprocal of sine. We don't want sine to be 0. Where on this interval is the sine worth 0? Well, that would be at y equals 0. Sine of 0 is 0, so y is non-zero here. And a similar definition for the arccotangent. So an equivalent would be saying that the cotangent of y is equal to x. So remember, cotangent is cosine over sine. So here y is in 0 to pi, and we don't want a 0 denominator. All right, so we'll run through a couple of these. So we'll do the arcsecant of 2 root 3 over 3. So we'll use a let line, let theta equal the arcsecant of 2 root 3 over 3. Take the secant of both sides, and secant theta is 2 root 3 over 3. So that means 1 over cosine theta is 2 root 3 over 3. So 3 cosine theta is 2 root 3. We'll divide both sides by 2 root 3. My apologies there. 2 root 3 cosine theta is 3. So cosine theta is 3 over 2 root 3. And we'll rationalize that guy. So 3 root 3 over 2 times 3 equals root 3 over 2. So cosine theta, root 3 over 2. So hopefully that is coming to mind. Theta would have to be our friend pi over 6. So that nice pretty 30-degree angle, that first one on our unit circle. I'll try one out. So I'll try the arccotangent of 1. So give that a pause, give the video a pause. Okay, welcome back. So our let line here, let theta equal arccotangent of 1. So cotangent of theta is equal to 1. So cosine theta over sine theta equals 1. So this means that their outputs had to be equal. That's happening at pi over 4. So that nice pretty 45-degree angle, sine and cosine agree. Also happens down in Q3, but that's not in our domain. So then, excuse me, the last thing they have us practice with is going from trig to an algebraic expression. So if we say that we want the cosine of the arcsine of u, we can say let arcsine of u be our theta. That's what we've sort of been doing already. So then sine of theta is equal to u. So no big surprises there. So then we want the cosine of theta. So just saying what arcsine of u is the same as, well, by our identities, sine squared theta plus cosine squared theta is equal to 1. So cosine squared theta is 1 minus sine squared theta. So cosine theta, we'll use the plus of 1 minus root 1 minus sine squared theta. Well, if sine theta is equal to u, sine squared theta would equal u squared. So cosine theta then is square root of 1 minus u squared. Now we've turned it into an algebraic expression on the right-hand side. Okay, so from 7-2, I'd recommend 9-43 the odds, 57-65 the odds. I would recommend doing these without a calculator unless the book specifically asks you to do that part, estimating with a calculator. And again, as usual, I'll make an equivalent MyMathLab as well for those of you doing the MyMathLab version instead of the book version. All right, if you have questions, get in touch with me. Otherwise, I will see you next time. Stay safe out there.